Good morning.
How are you?
I'm doing well. How are you?
I'm good. So yeah, I looked over what you proposed. I'm certain I have a few questions we can go over. Um, but yeah, it's really hard to understand why something exists without first understanding the requirements to it.
Yeah.
Right? So that's the kind of thing I want to do. So let's see who else shows up today. But what we can start doing is I can share my screen and we can start going. Might as well just do it first. Going over your um, proposal here, which is right here. Okay, so you start with intro, but there is no like requirements. There could be like a reference to a requirements doc, right?
Yeah.
Um,
This was thrown together from my notes just before
mhm,
heading to bed. Um, so this is definitely rough around the edges. Um, but the motivation here was uh, basically that I had noticed uh, from your original document that you had shared on Google that I just thrown into Hedge Docs to get it formatted. Uh,
mhm,
that uh, and plus from reading the IETF draft, already have uh, an optimization or the keys required for an optimization that I've been working on in the C
yeah,
working group for the passport model for attestation.
right,
Because all of this talk has been about background check. That's very slow in comparison to everything else. So I basically just saw a bunch of um, for the lack of a better word, synergy between stuff that I was working on, the stuff that I was reading. I'm like, oh, I wonder if this stuff could fit. So
yeah,
effectively, the reason why I'm proposing this is basically just as a speed up reduction in round trips for when there's a large spike in uh, workload entities that need to come up, grab credentials, and start doing work during a moment of high demand. Uh,
right.
Basically, that's I'm
Okay, so the goal is performance. Okay.
yeah.
So, uh, okay. Well, I mean, uh, I guess here the first thing that jumps out, which I'm not, I will not even say is a bad thing, but it just as an observation. The first step is you're sending your evidence to the verifier. So immediately we know that verifier needs to be up pretty much all the time.
Nope, nope. Passport model. So this is
You send it up when verifier is available,
yeah.
and then basically you're saying if it's not available, you already have a certificate here. How is that provisioned? If you're going to do MTLS with a signing key, how is that provisioned? How is that certificate provisioned? Is that just out of band? It exists, it doesn't require remote attestation, or is it something that does require remote attestation?
So the that uh, those are things that can be ironed out. It depends on right now. This is mixing both Bootstrap and steady state operations.
Right?
Uh, so uh, it like EST, I believe, already has uh, something in it for when you have nothing at all, right? Because EST is about automatically obtaining a certificate. So when you don't
Yeah,
have anything at all, you start with a bootstrap somehow, some way. In this case, the CSK is the ephemeral key, and either it has already been attested, before like there's already been a provisioning step or this
Hmm.
is the provisioning step. It depends on what the life cycle is. This is very abstract. Um, but
Right.
this particular block here is just kind of like a background process. So rather than having the attester constantly having a rat's unaware relying party, which it doesn't do any of that, is not ever required to go and say, "Oh, I need to reattest this thing because it doesn't know and doesn't know to ask for that, doesn't understand what that is." There's just a different background process that constantly refreshes the policy, co-RIM, credential, endorsement store that actually understands what the AR
Right.
appraisal policy is to give you your credentials.
Okay. So I think I've started to get it. But hi, Michael. Thanks for joining. I just want to make sure
Hello.
I'm gonna put the meeting minutes in the chat so you can add yourself. Um, and um, if I may, I spent a little bit of time uh, over the last couple of days, and I sketched out the sort of a picture of how this. And by the way, Michael is to be credited with this idea of an EST extension, EST being the protocol for acquiring certificates. The more I look into it, the more I like it. I also realized that it's still not compatible with SPIFFE and Spire. So I was looking for something.
Yeah, it's not perfect for that either.
But if you let me,
Uh,
I'll show you how I believe we
go
can
ahead.
make both work. So I'm gonna share something else. I'm gonna share this app.
Um,
This is my OneNote scribble. Sorry, excuse the scribbles. Can you see it?
I'm going to have to switch browsers just a second. Oh, that worked.
Okay. So
Oh, interesting. Okay.
Let's read it from the bottom, and let's not worry about the Spire SPIFFE piece yet. But there is a workload here on the bottom, and it talks to an EST client. I later observed that the EST client can be outside the trust boundary, which is kind of nice. And this EST client, we need to, what it says here in my scribble says define interaction. So this says define interaction. So basically there is going to be some kind of API that we can say to the EST client, like do a thing, and it will do a thing. And that will go to the EST server. And the EST server, in this case, is a plugin to a certificate authority, right? And then the EST server will supply the evidence to, like, forward the evidence from the EST client to the verifier. And I'll get back some sort of response, which it will then forward to the workload. And we can define exactly what the EST extensions are going to be. And it turns out that there is plenty of open source stuff on which to build the EST client and the EST server. So I went and looked. So there is a bunch of stuff that's written in Go that should be fairly easy to extend. And then the beauty of it is, so this interaction may be, okay, give me the freshness, and then the freshness comes back, and then it will be, and now give me a key or credential, and then the ST server once again will go either mint a new credential or return an existing credential, which is what EST already does. So it should be fairly simple extension. Then the beauty of this is if you now remove this whole EST client server blah the top part, everything above the green box, you can say, okay, we're going to define the Spire API that's basically a tested workload API, because workload API in Spire is parameterless, right? And then you can basically say, all right, I'm going to have the same API between the workload in the ST client as I would have the API between the workload and the Spire agent. And then this entire thing in black, ST client server, whatever, gets replaced with Spire agent that does what Spire does, right? So then we can basically, with one architecture, we can have both mechanisms supported in exactly the same way. Okay, so I'll stop for questions right here.
No, questions other than maybe affirming an understanding or misunderstanding. So the way that Spiffy Spire works is with selectors and like a workload attestation process, uh, right? So is that
Yes.
the when I was reading about using an AR and an appraisal policy to go and say, okay, use the AR to figure out what credentials the workload needs. Is that basically the same sort of thing that you had in mind for
Yeah,
what
I have
Spiffy
in mind
does?
basically, yes. I mean, the thing about agent and workload in Spire, the way I understand it is that again, workload API is parameterless. So the workload can go to the agent and says, I want my credentials, right? Saying nothing else. So this means that the agent needs to understand who this workload is, how, like, and I think it's really done out of band by the agent, and it depends on the operating system implementation. Maybe it needs to do some introspection to figure out what parameters to use for the selectors and whatnot. So there's a lot of TBD in there, but I believe that uh, you know, the workload API is not going to work. I'm going to run this by the Spire guys and basically say for a remotely attested workloads, we will just need to define a tested workload API, and it will not be parameterless, but it will be sufficiently generic to contain the two operations that we really need, which is one, get freshness, and the second one is now give me what I need based on this evidence.
Hmm.
So uh, I believe the interaction with the ST client is ultimately the same interface. It's just the Spire workload will convert it into its own way of communicating with the Spire server, and the EST client is going to convert it into its own way of communicating with the EST server. And then we effectively defined an all-encompassing mechanism. Now, if you just keep this picture in mind, let's switch out back into what you propose, Nathaniel, so we can
Yeah,
see if if the requirement.
how it
First
works.
of all, let's see if the requirements that you have advertised actually work, right? Um, I think that's kind of important. Or do we really need to go with doing some of what you suggested? Because again, here the workload immediately goes to EST, like the box isn't here, but it can go to EST client. Now, it could go to EST client either with attestation results, meaning it itself contacts the verifier, or it can go to the EST client. So this would be your number three here. There is some sort of interface between the workload and whatever may return credentials.
If you scroll down a little bit, there's the swim diagram.
Yeah.
That's
So your EST server here has to have an updated TLS stack because it needs to understand this.
uh, so that would be Uh, right. So either a custom library in the meantime, or if Seat standardizes a particular in handshake flow, which is what they're doing. That's what the remote attestation extension there is. That's how it would be done. So what is unique to what I'm proposing is the in-band proof of possession with the credential encryption key. Um,
Right.
but
But so here's the thing. Here you're
yeah,
basically saying we will need to update the MTLS stack and on effectively every endpoint we communicate with. So uh, I I hear that. My questions then become, so first of all, uh, I'm very, very scared of changing protocols, especially such as MTLS, because protocols are hard and because changes may introduce vulnerabilities, and those vulnerabilities may surface years later, right? That's sort of, that's just a fear. Maybe I'm just paranoid. And the second thing is, you may run into issues with, n- it, I guess if only if the only thing we change are EST HTTP commands, then we're effectively working at the EST application layer. If we start changing the EST MTLS implementation, that we're now also changing, maybe also or only changing the EST transport layer as well, right? So all of a sudden we have changes at two OSI stack layers, which again,
I'll
makes me
just say that
paranoid.
this is not so much a requirement. So this is basically just like taking the changes that are being proposed for EST
Yeah,
and saying, okay, as things are right now, um, uh, just working over HTTP, the RESTful API that EST has effectively, that's fine and good. But what I found was basically that because EST already does MTLS, and because the like I actually have a proof of concept actually running that does the chem challenge in band in TLS, but that's just a private proof of concept that I've written a while ago.
yeah,
But I just saw that, oh, the stuff that I was working on independently meshes really well with this. So this is not so much this is what you guys should be doing instead of what you've proposed with EST. It's more like this is how this could be enhanced for performance and speed moving forward. So it was more of a, I like the direction that you're going with the EST enhancement. And then on top of that, because you already have the CEK and you're going to do uh, a challenge specifically to say, okay, prove that you can actually
yeah,
decrypt secrets we give you. Um, I already have a process for if you have a confidential container and that confidential container just so happens to not have a confidential signing key, which is a use case that I have seen come up several times in seat discussions. Basically, um, they want to be able to take a certificate manager, they want to take a non-confidential key, they want to inject that into the container, and then um, move forward with that. I'm like, okay, but now you don't have a confidential key on your confidential container. So the the additional chem proof of concept where you have an ephemeral chem that proves that it can take a secret, decrypt it, decapsulate it, prove it, and have that in the attestation results. That whole process that we were doing is effectively what you have proposed in your
yeah.
TWI thing.
So,
So
right.
this is all an optimization.
Yeah.
So
I understand. So before we optimize, we need to understand that we're building the right thing, right? So
yeah,
it has to go in that order. And I really do believe that the right thing here, just popping up away from abstraction, like which protocol do we change, and all of that, is specifically the thing that jumped out at me from the previous diagram that I shared, and the property I would like to be able to preserve
yep.
is that I don't always know what my control plane is going to do in order to help me get my credentials. I don't always know this. So it has to work in the Spire land because again, SPIFFE is a big enough standard with enough following, and there's this whole whimsy working group around it, and it would be really
Yeah.
nice. And also, if again, I do not like inventing new protocols. I'd like to reuse existing protocols. So when Michael came back and said, "Okay, let's do EST," I was first like, what is it?" And the reason I like it is because, well, it solves like it addresses the problem, which is how do I get a credential? Now, it doesn't have this particular authentication mechanism, which is remote attestation, but it basically it provides the framework within which we can say, well, You can do over HTTP, you can do this thing. By the way, client authentication in this case, it could be MTLS, it could be remote attestation, it could be like any number of things. But what I don't see about your proposal is I don't really see how to plug Spire into it.
So the basically the um right at the so if we go so number 16, right? The post well-known attest credential, and then 17,
Yeah.
grab the encrypted
Yeah,
credential
but
by
this
the
is this
that
this is okay, this is the ST now. But I'm talking about Spire. In Spire, none of this
but
exists, right?
um uh okay. So let's go back to your thing. I just wanted to uh, have the attention there. So if we go back to can we go
The
back to your
scribbles.
whiteboard?
Yeah.
Yeah.
Right. So there is going to be an API here, right? And the workload, the way it talks to ST client, it could be gRPC. I mean, who knows what the transport there is going to be. But
Yeah.
you know that you're going to have something on the other end of you that follows a certain protocol. Who knows what it is? But the fundamental primitive is I can give it a request and it's going to give me a response. We can define what those are, right? And it appears like the EST client could translate that into its own language, which is posts over dot well known and everything else. And the Spire agent can translate it into its own mechanism for talking to the server, that being selectors and whatnot, right? Which effectively means we now abstracted away the mechanism, but we are defining this API that so long as you implement this API, here's your proof of concept. This works with EST. Here's your proof of concept. It works with Spire. And we changed no protocol other than we added a few commands to EST.
Okay.
See, that's the sort of that to me that is the kind of a sweet spot because it's the minimum required. You cannot do with less.
Okay, so the way that I had interpreted this chart was that effectively the workload would first talk to the EST client, would download something equivalent to a spiffy SVID from the EST, and then it could cooperate with existing Spire systems. But what you're actually suggesting is that whatever API um, setup that y you configure or define
Yeah.
um, would work with either EST or with Spiffy
Exactly,
independently. Okay.
exactly. And then the thing is, whatever comes up in the next 10 years, as far as here's another, protocol for procuring credentials, we can basically say, look, so long as you, uh, A, give us freshness, and B, take from us a well-defined blob. And again, we'll get into details, but maybe that blob is evidence, maybe that blob is, attestation results, then everything is going to be great because we will support all of your, well, however you want to play it. And again, the code will speak louder than these words,
Yeah.
and we'll need to figure out, do we support both passport and background check model? So maybe workload wants to go talk to the verifier directly and then just, employ attestation results. But even like however you slice it, caching is still possible. You can still recognize, this is valid evidence, and this evidence is I recognize this evidence, so I can already pre-treat it as valid, right? You could be doing things like that.
Right. So now I haven't had extensive hands-on time with either the Keyline plugin or Spiffy Spire in anything other than home lab stuff at the moment.
Yeah,
My background just hasn't needed it, but my understanding from looking at understanding and exploring how Spiffy works, or the Spire server is that uh, basically the as long as the policy basically I see almost a direct parallel with the TWI credential broker reading the AR to say, okay, uh, I understand this AR means that you are this workload, you need this credential, go.
Yeah,
As the same thing as a Spire agent coming in and saying, this is these are my selectors, this is what I have. Um, and then the Spire agent saying, oh, okay, based off your selectors, you belong in this group. Here's your credential, go. It's basically almost the same thing. It's just you're one is doing it with IETF machinery, and then Spiffy is its own thing, but basically the same kind of parallel workflow. So all of that seems to make sense. In terms of how my thing would work with Spiffy is basically the same sort of thing. There'd be a particular plugin that would be written in Go or whatever else that would basically say, okay, we want to use Keylime for attestation, um, uh, but we're also doing confidential computing. And so this is the thing where a selector can say, okay, uh, I have a CEK, and I'm going to prove that I control it. So,
right.
and then uh, the plugin goes through the process, and that plugin allows us to basically tell the Spiffy Spire whole system, this is the interaction that we expect in order for a SFIT to be delivered, and then off to the races. That whole process can be defined. Now, in terms of getting that to mesh with what we're doing with EST, um, we'd play around with it, but
Well,
I
but
don't
I
have
see here,
enough
so
to articulate
there
how
is
it would
no
work.
expectation that Spire would speak the EST protocol here.
No, no. But in terms of the API that you're defining as the glue,
Well, the
right?
glue is like again, if you consider that the glue in the simplest case is basically two calls. One is give me a nonce, right? And B is here's your evidence. Let's just forget about attestation results for a sec, right? So in that case, whether it's EST client that will translate it into its own set of commands, or it's a Spire agent that translates it to its own set of backend interactions, nobody cares, right? And then if it's some future-looking thing that does whatever, um, then uh, then great. I mean, it's ultimately the same beast, right? And
Right.
yeah, then we can further embellish it and say, well, in this case, you give me a nonce and I give you a, CSR, uh,
Okay, so
right?
this is this that then I think that I have enough to articulate for now, is that the way that I understand like the limitation that Spiffy Spire has with confidential computing is that the credential that the Spire agent is handing um, to the workload is not it's not a confidential
Well, two things.
credential.
First is the workload API is parameterless, which means there is no way the workload can communicate information about itself, right? There is no way for it to say, here's a quote or here's evidence.
Right. Um,
And the second problem, you're correct, is that the API is defined in such a way that what comes back is visible to the agent as well as the client. That's unacceptable, right?
right.
So that API, workload API as is, cannot be reused
Right.
without it, like some massive hack.
So
Uh,
that's where I saw the credential encryption key that you're using in the IETF draft to say, uh, we're going to take a credential, we're going to wrap it in this. That
yeah,
CEK is ephemeral, it is confidential, it's per workload.
yes,
That whole thing um, can be also used as proof of possession of a confidential key in
correct.
absence of a signing key,
Right.
in absence of a
So the
confidential.
only yeah, everything you said is correct. I will also just caution that if it's the credential encryption key that we're talking about, then it's done on the expectation that the whatever credential gets returned is a pre-provisioned credential. It already exists, and it will be fetched from some key store, and it will be returned encrypted to the workload and returned.
Right.
But it does not handle the case where each returned credential is freshly minted, because for that you need proof of possession of a signing key. And that's why I'm saying the minimal API will have one or the other. But for the real world, you'll probably want to be rich enough to say, here is a mechanism for us to get pre-provisioned credentials, and here's a mechanism for us to get freshly minted credentials.
Why would you need, sorry, I'm not following. Why would you need the signing key for freshly minted credentials?
Because that's a CSR, right? So basically, in order for me to issue a credential to a signing key, I need to know that the requester is in possession of the secret portion of the signing key, and that's what CSRs do, right? Correct me if I'm wrong.
Okay,
Say
right.
that
But in
again.
terms of, okay, so the way that I have, Uh, again, this goes back to the security considerations of just operating with a T in confidential computing with seat, and that's an ongoing conversation that hasn't
Yeah.
been resolved yet. But basically, is that if you have a system that is handing over a non-confidential signing key, it doesn't matter if you can prove possession of it or not, because it's not confidential. There's that lacking um, uh,
Well, there
thing.
is, if the credential is pre-minted, then somewhere in some HSM, in some key store, there sits a signing key, and there sits maybe a corresponding certificate somewhere. And if a workload can prove possession of an encryption key, which is, yes, ephemeral, asymmetric, then we could use that to say, oh, let me take the secret, which is the signing key and the credential, wrap that bundle to your encryption key and return it to you through, a dumb
Through whatever
router.
process, right?
Yeah,
So
right. So
basically, what
thus
I was just
becomes a
saying is that that whole system, I love it. That I was like, oh, this can also be used as a proof of possession, an interactive proof of possession in the absence of a confidential signature. Uh,
correct. So, but again, in that case, you're basically signing up for multiple workload instances sharing the same exact credential, same exact signing key. And that very well works for enterprise scenarios where you're spinning off like thousands of containers. You don't want to mint a lot of new credentials. But I also believe that there needs to be a protocol variant that says, no, if you absolutely insist for whatever reason that your credentials be freshly minted, and every workload has its own credential that's, only it can leak, and no, like the blast radius is then that workload instance, then you also need a CSR-like mechanism. So that's what I'm saying. Like, unfortunately, we need both, and that complicates the protocol and it complicates, these interactions.
yeah.
And it's perfectly fine to implement one proof of concept, but it needs to be extensible to another proof of concept.
Okay. Yeah. So I think basically, uh, I would just take what I've put together as a sketch, and it just sits in the back burner right now because Seed is still in the middle of doing its own thing.
Yeah,
I just saw, hey, the stuff that I saw in the IETF draft and the new thing with the EST, and again, the uh, the whole process of a proof of decryption, like proof that you can actually use this key, um, is basically the same thing as the proof of possession mechanism that I have in absence of a confidential signing key. I'm like, these things can just be meshed together. In terms of how that would work with EST versus Spiffy Spire, that's
yeah,
definitely an interesting question. And all of the things that need to be done for TWI in general can happen independently of the speed optimization. So basically, I just saw that there is an opportunity to offload the whole background check and attestation process to like a background process that's not part of this uh, uh, regular interaction. So the
yeah.
workload is somehow provisioned one way or the other. It's bootstrapped, or and that entire thing is currently also getting meshed. That needs to
So,
be
so
separated
yeah,
out. But
so this to distill the requirements is, um, yes, we need to figure out what can be cached for, future optimization and resiliency. That should be considered. But before we go into optimization, let's satisfy the core requirement. I really believe that the core requirement is the workload needs to be able to utilize existing mechanisms, like slightly modified, but largely existing mechanisms for getting certificates or credentials for itself. And again, credentials could be bearer tokens. Unfortunately, they can be uh, proof of possession, like WITs, or they could be XONS certificates, right? And if somebody wants to use EST because that's what they have, or if they want to use Spire, if that's what they have, we should define something that ideally looks very similar between the two,
okay,
right? Because if we
let
do
me
that,
let me
then
yeah.
the path to adoption is cleared.
Yeah. Let me just I don't know if I'm going to I'm my thing isn't set up to share. I have not my own sketch, it's from Alan DeCock who shared it with me. It was
Yeah,
he was sharing
go ahead and
how
share if you have something.
uh I don't have the uh my workspace is not set up for
Hmm,
presentations at the moment.
I see. Okay.
So I'll just articulate it. Basically, I was talking to him about the radio servers and provisioning network access
Yeah.
over radius for enterprise,
You mean
and
to the end users, or do you mean to the radio servers?
to the radius servers was the specific
So the
discussion.
proxy mechanisms between radio servers, not to end users.
It was specific.
I'm
It
asking
was
very, very specifically because those are two related but different problems.
Yeah. So this is the there is something that is authenticating to a radius server to gain network access. Um,
So an
and
end user is authenticating over radius to an AAA server.
right. Um,
Okay.
uh,
Radius
and
is just a transport here. It's not a for EAP.
right.
Okay.
Um, and he was specifically talking about the EAPs and how there are several different EAP flavors for the TLS um, portion of it. So, in terms of getting the credentials packed into the tunnel and then in a way that the Radius server can then read and unpack and make decisions, or that it was talking about the transport. And basically I was asking, okay, so for EAP TLS with attestation, what would the requirement for that be? And the conversation I had with him was before I understood that this may already be a pattern that exists. Um, but what he basically articulated was very specifically that there are many different flavors of EAP. Um, uh, on top of TLS, and then EatHog also has its own EAP profile. Um, but in terms of attestation, uh, it, having a per protocol or per profile attestation thing for each different EAP would be like a non-starter. Um, but if there was attestation that was baked into the handshake of TLS, then effectively the radius server might need to know that an extension exists, but once it knows an extension exists, it needs that update. The library needs an update, but once that's done, it just knows, oh, I can look at this extension. I know to
So
ask for it. I know
I
what
just
to
want to
read.
pick
Yeah.
detail because it matters. It's not a radius server. It's the AAA server.
Okay.
Sometimes that's
Okay.
in the reason I'm being pedantic about that is
Yep.
because um the final step where EAP is unwrapped is often is the radius server, but it's not always. It can go all the way further to another piece.
Okay.
But yes, it's essentially EAP TLS is TLS from supplicant to AAA server,
Yeah.
and we can revive, we can we can change that TLS. We can extend it. We can do a tested TLS or whatever we're calling it this week within
Hmm.
that without necessarily changing any of the infrastructure. And that's why that's better than uh, than a method specific attestation.
Yeah.
On the other hand, um, there are there are EAP methods for which attestation would look very different, and they're very valuable. For instance, EAP SIM. Okay, and so it's not exactly separable, particularly on the client. Right? They're all wrapped up together in different ways, but um, going around trying to add remote attestation to all these different EAP methods is probably a problem, but adding it to the EAP TLS might wind up with you actually evaluating the wrong thing,
Okay.
right?
Um,
So are you interested in in how well my phone is doing for malware, or are you interested in whether my credential store within the TEE, the eSIM, is sane? Those are two different things,
yeah.
and you may care about both of them. You may care about one or the other, but they're not the same thing. And doing it to the EAP TLS might not get you what you want. So I'm not sure how that fits into that space. But also, there's also this thing called EAP TEEP, which purports essentially to replace. Um, it's a Cisco, hardly even Cisco thing at this point. Um, Apple and Google have said they will not implement, for instance, and Microsoft probably won't implement the fixed version that actually will interoperate. So it was probably dead in the water. But um, it essentially presents itself like it's EAP TLS ish, but more HTTP ish, and it does certificate provisioning. So it is a competitor in some sense to EST, although you can backend it into EST. Um, but it's a different way of doing things, and so in this context, yeah, you could do it that way, but I'm not sure it helps anybody. Anyway, continue.
Okay.
Sorry.
No, that's okay. I appreciate the pedantry, actually, useful. So the point of what I was trying to say, and it was really an aside, is that the stuff that I'm looking at, and the reason why I'm like, oh, put attestation into the handshake, is because that is something that like there's the working group that's working around and with that with Seat, obviously. Um, and it was the conversation specifically that I had with Alan about Open Radius, EAP, AAA servers, all of that stuff, where I learned about the fact that you have something like EAP TLS with its own RFC that only does in-band authentication. Like it prohibits any application data frames for what it's doing. Now, there's other flavors where stuff can be tunneled, but for that particular thing, that's all there. So that with what Seed is doing, Seed is looking to standardize a standard approach for sending attestation back and forth over a transport. Since EST is using TLS, it's using MTLS. I can see uh, it seems realistic to me, basically, that even if Seat does a post handshake exported authenticator process with RFC 9261, all of that stuff, that there's also going to be a standard for in-band attestation at the or TLS level. And uh, the change that an EST server would need is only basically awareness that the extension exists. Everything else about an EST server could be exactly the same, um, uh, minus that. So, what I put together as a sketch is definitely very forward looking, but part of it was also to see if I could if I actually understood what t the TWI credential broker and EST proposal was actually doing. And it seems like the optimization is premature because there's other things that need to be sorted out. But I think that I get it. I think that I don't have any open questions about how the credential broker process would work. Once, like, all of the attestation happens isolated, um, with the workload grabbing the legacy credentials, whether it is a freshly minted credential or if it is wrapped up in a CEK, whatever the case may be. It grabs that and then it talks to the rats unaware relying parties, and there's no attestation there. It's all pre-attestation, but that's passport model anyway. Um, so basically, I'm quite happy to keep my sketch in the back burner. It's not something that I think needs to
But
be
will you
spent a lot of
email it
time
to us
thinking
when you
about.
find it, since you can't share it?
Uh, s- uh, the
Because
the
you said you weren't set up to be able to share that sketch.
let me just find. Sorry, when I said so that I use Sketch in two different ways. There is just a wait, a silly diagram. Can I make this full screen? Um, Okay, let's see here. Share. Don't know why I'm getting exclamation marks. Oh, okay. Um, sorry, when I said sketch, I mean the sketch is in uh, the proposal that I put into the Google Doc, and the
Okay.
other sketch is the actual visual. But they're not quite related. So the visual that Alan did was just part of the discussion, and I was just going to talk it over. Um, uh, because there you could be like, okay, this is where the AA server is. But come on, let's I'm fighting with my computer at the same time. One sec.
I'm just gonna rejoin just a sec. No, that didn't fix my video.
Michael, you and I will need to probably decide if we're going to do the POC, what stack to build it on. Let me give me a couple of days to come up with a proposal, and then we can talk it over. Oh wow, pictures.
Well, it's a pretty
Okay, I was
diagram. You
muted.
just need to make it slightly bigger. Isn't it the plus button that you want?
Yeah, sorry, I didn't realize I was also. So this is the diagram that Alan and I were talking about. This is not a proposal to you guys. The sketch, what I was saying was my proposal that's in the Google Doc. But he was basically just explaining that there is there's the TLS tunnel, but then there's EAP, and then Radius rides on top of that. And it was talking about just the communication between Bob and whatever's on the other end. So this is not really useful anymore, so I'm going to stop sharing that. Um, but that's what I was talking about with Alan. He was basically just giving me a crash course effectively on Radius. And because I had questions about how attestation would work with the stuff that he was doing. And he basically just, the bottom line with that was simply that having attestation changes on a per profile basis, um, that's fine. But if it's the only option, that wouldn't make any sense. Uh, for what is happening with EST, of course, making the changes to EST, adding attestation the way it is over HTTP, all of that's fine. I just basically saw, oh, this can also turn into something that can, uh, remove 4 or 5 round trips potentially once all the APIs are worked out. Um, this all seems to work. So I think that the uh, the stuff that is proposed with the EST, I think it makes sense to keep pursuing it. In terms of the Spire stuff, I know Manu isn't here this time. I just overheard from last week's conversation. He had a plugin for uh, confidential computing that he might be able to add additional insight uh, for the group for. Is that what he had um, suggested, or did he basically just affirm that it's possible?
I will let him speak for himself. You can
Okay,
shoot him an email, man with Hashmesh.
okay.
Yeah.
Um, but I think all this makes sense. So the core proposal or enhancement that actually matters is saying that the CEK or
Mhm.
the TEK that whole um, key encapsulation key that can
Yeah.
be used as a ephemeral confidential proof of possession without additional pre-provisioning. It doesn't need a CSR. It just needs to basically go
Yeah.
through an attestation
Right.
process
But
with a
also, it does
verifier.
not work for freshly minted creds, right? It only works for distributing creds that already exist.
Uh, 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 right. But what I'm saying is that that particular mechanism can prove that the machine is live to grab or to like to get a freshly minted certificate uh, in the passport model without having the verifier on the line, because that's the whole thing, is I'm trying to say we can have the verifier out of the hot path completely because we can have that confidential CK or key
Yeah, it's
EK.
certainly like well, I mean, the verifier still needs
Yeah.
to look at the evidence, but I mean, maybe evidence is cacheable so long as the signature checks out, right?
Yeah.
Yeah,
Um,
and so that's the major feature of the passport model is that, as you say, it can be kind of, in the back office, as you if you like, or a lot of other, things, and the attester mostly gets to pick who the whose verifier they use, internal, external, blah blah blah. The challenge is, of course, is that you got to get the relying party to actually trust that verifier, and um and
Well, I mean, it needs to trust the certificate issuer. It doesn't need by the way, Michael, this is actually a very important point. This is not a technical reason. This is regulatory reason. The relying
yeah,
party
no,
are you talking about the rats relying party or the ultimate relying,
yeah,
the rats node?
the rats relying
Oh,
party,
the rats relying party needs to trust the verifier, of
so in
course.
general, now this is the point I'm trying to say, is that in general you have this problem. You can't just mix arbitrary verifiers with arbitrary relying parties, and there's a bunch of people out there who think this is the open wide web of stuff. It's like, no, you're just, it's not the case. You're going to have trust relationships. Sorry. Okay.
Hmm.
So um
yeah.
now in this case, um of, what we're trying to do here, I think it's fairly easy to uh have the rats relying party trust whatever verifier you put up, but the verifiers that you put up.
Yeah.
And uh, um and that's fine. And it has it's, I think that passport model is also much simpler because you never have to encrypt your any of your evidence. You don't have to worry about it being disclosed, and you don't have to worry about the verifier somehow getting replaced by some other one due to a change of business relationships or something like that, right? But Nathaniel, does that fit into your space of what you were just saying about keeping it
Yes,
out of the
yes. So
main?
the passport model is it simplifies a bajillion things. So if we're focused on minimal amount of work needed for a workload to like it's a lot. Uh, well, the workload is going to need to do that provisioning process, get the first background check, or like get its first attestation results somehow, some way. But after that process, the biggest challenge that I found and like the security gap is that uh, the uh, if the signing key that's typically associated with the attestation report for a workload is not confidential, then there's no real point in having done the attestation. So
Yeah,
the backup of having a KEM, key encryption key, to prove live proof of possession of a confidential ephemeral key that the workload just so happens to have, thanks to the trusted application that's generated it. That provides the proof of possession so that you can have the flexibility. That's not to say to the exclusion of a
hmm
confidential signing key, but in the absence of, you could have the absence of a confidential signing key, and you could still have that attested proof of possession. And it just so happens that the proposal that I'm reading through at the TWI for a ephemeral credential encryption key is effectively uh, isomorphic to what I've been looking at with the seat working group about, okay, Passport is much more performant. If we want any adoption whatsoever, we need to not force everyone to have a background check every 5 minutes, a disconnect
right.
and a reconnect. And so that's all that. And I just saw that parallel. So um, that's basically it. I think that the TWI idea makes sense. Of course, there'll be a background check process, but I think that it could use the passport model for speed and efficiency for spiky workload demands. And it just so happens that the existing mechanism and ideas that you have for using the AR to uh, the appraisal of the AR to say, okay, uh, you need these credentials. Here's your credentials, and the CEK process, that whole thing, just like it's a shoe-in for the stuff that I've been looking at. So that's why I'm so enthusiastic. That's why I keep showing up. That's why I'm so verbose, is because it's like, oh, you guys have been working on this completely independently of the stuff that I've been doing, but it looks like there's a very easy mesh here. And none of this is expecting the workload to have the ultimate relying party understand what RATS is at all.
That is
That's the other
so,
thing.
so, so very important. Yes. And
Yeah.
Yeah.
So I just wanted to understand. That's a good point you made about disconnect, reconnect, uh, attested TLS, and having to redo everything again. Um, you don't think that TLS session resumption would cope with most of that?
I am fighting very, very hard for resumption to exist for absolutely anything seat does. I do believe that it's important, but I also don't think that the background check and resumption works very well. So that
Okay.
right,
Yeah. No, I hadn't thought about that problem, but I think you're absolutely right. And just kind of like, oh, okay. You know, I don't know what seat is going to be used for. I mean, there's all these workload stuff, but somewhere's in my head, I was, thinking about um really long-lived TLS connections, like, one that you talk to.
All right, folks.
I was going to say
Unfortunately I
your
need to drop
iSCSI,
for another meeting, but please
All
continue
right.
without me.
but anyway, listen, I have to go. Uh,
Well,
I got another meeting in
it's nice
I'm
to
late already.
hear your voice. We haven't spoken directly yet, so
Yeah,
nice to talk to you, and
nice
we'll
to
talk
meet you.
again later.
Okay, thanks.
Right.
Bye bye.
Bye bye.